Hi, this info session will show how Copernicus data can be used to support the mitigation of heat waves and urban heat island effects on small to large cities. The urban heat island is the effect whereby the air temperature in densely urbanized areas is higher than the one of nearby low-density and/or rural areas. This effect is particularly evident during night hours. The urban heat island effect on certain weather conditions can cause prolonged periods of excessively hot conditions that can cause a so-called heat wave. Urban heat island is responsible for various negative effects on cities, and these effects become even stronger and dangerous during heat waves. Such effects include discomfort for the citizens due to thermal stress, which can lead to death among the weakest part of the population. It also causes an increase of energy consumption, especially for air conditioning, which in turn influences the atmospheric chemistry, increasing, for example, the ozone level. Also, the local meteorology of cities is modified, leading to increased rainfall. The local ecosystem, too, is impacted by the higher temperature of water areas. Finally, also the increased water demand has to be taken into account. So, the knowledge and the monitoring of the urban heat island phenomenon is important both for public health, including proper urban planning, and for the environment. To understand the urban heat island effect, we need to look at the surface energy balance, which determines the air surface temperature of a given area. The main source of it is solar radiation, to which in large cities we add the anthropogenic heat, for example, from combustion of fuels and animal metabolism. A part of this heat is released by the soil surface and exchanged to the surrounding atmosphere. This is called the sensible heat flux. Another part of this heat is released by the surface coverage through evapotranspiration and doesn't affect the air temperature. This is called the latent heat flux. Finally, a part is absorbed and stored into the ground. So, the air temperature is mainly driven by the heat emitted by the soil surface. The less heat is released by vegetation evapotranspiration, the greater the part which goes into air temperature. This, for example, occurs in many large metropolises. The surface energy balance is generally evaluated by models. Remote sensing from satellite can provide useful information as input to these models. One is the estimation of the land cover, and another is the measurement of the soil temperature, or land surface temperature, which is directly related to the sensible heat flux. Copernicus provides various sources of remote sensing data useful for measuring the land surface temperature. Currently, near real-time measurements can be achieved by Copernicus contributing missions like Meteosat second generation and MET-OP-A and B. The Sentinel-3 mission consists of 2 satellites which, when fully operational, will provide near real-time measurement of land surface temperature at a spatial resolution of 1 kilometer with a repetition frequency of about 1 day. The Copernicus land monitoring services include the Copernicus Global Land Service, which provides access to low-resolution land surface temperature measurements on demand over the whole Earth. Such service uses the above-mentioned missions and other ones that are freely available. The main other free satellite sources for measuring land surface temperature currently available are MODIS and VIIRS at 1 kilometer spatial resolution, Landsat 8 at 100 meters, and ASTER at 90 meters, with different repetition frequencies and spatial resolution. The Sentinel-3 satellites are equipped with an instrument called Sea and Land Surface Temperature Radiometer, or SLSTR, which provides 2 thermal channels for measuring the sea and land surface temperature. The LSTR instrument represents a continuation and extension of the previous ERS-1, ERS-2, and ENVISAT missions, which provided reference land and sea temperature measurement from 1991 to 2012. The LSTR instrument incorporates the basic functionality of previous sensors, with the addition of some new, more advanced features. Measurements of land surface temperature from remote sensing are used in many applications. It is generally proportionally related to the air temperature, in particular in urban areas. For this reason, a proxy for the Urbanic Island effect, which by definition is related to the air temperature, can be considered the surface Urbanic Island, which is related to the land soil temperature. As we have seen before, land surface temperature is among the parameters which allow us to model the surface energy balance. The identification of hotspots in city areas is an important input for urban planning. In particular, long time series help in estimating the effects of such planning related to city growing combined with the climate change effects. The following part will show an application of satellite land surface temperature for estimating the Urbanic Island effect over a large metropolis. In order to show the potential impact of land surface temperature measurement with Sentinel-3, we have chosen a MODIS LST Level 3 product for this demonstration, since its content can be considered very similar to the former one. We will use the free toolbox provided by ESA, the Sentinel Application Platform, or SNAP. After opening the SNAP interface, we load the MODIS LST product related to the 2nd of August 2016, acquired over an area which includes Greece. It contains various bands and, in particular, LST day 1 km and LST night 1 km, which contain the land surface temperature measurements at a given day and night time. To show them in the right window, we double-click on their names. This is the night map. We can look at the day map. We zoom over the Greater Athens area, which includes the urban area of Athens, which extends beyond its administrative municipal city. The day land surface temperature is shown. Acquisition time is 11:10 a.m. UTC. Then we go to the color manipulation panel to assign a proper color scale. We need to select a color ramp from among the predefined ones. We choose the simple 5 colors color palette. And then we set the display minimum and maximum to suitable values. This is the resulting color-coded map. With the pixel info panel, we can read the temperature of a single pixel. The values of the LST maps are in Kelvin degrees. Looking at the day map, we can identify 4 hotspots, 2 agricultural areas and 2 urban industrial areas. The land surface temperature range obtained, looking at the pixel values, is reported for the 4 hotspots and also the registered air temperature at 2 meter height. Remember that the values displayed are the temperature of the soil, which is related to air temperature, but is affected, for example, by soil cover and type and by weather conditions. For this reason, different land surface temperature ranges can correspond to a similar air temperature range and vice versa. Now we look at the night map, acquisition time 10:15 p.m. UTC. And again, in the color manipulation panel, we select the 5 colors color ramp. Also in this case, we set the suitable values for minimum and maximum to be considered in the application of the color ramp. In the night, only the Athens Center hotspot remains visible at 10:15 p.m. UTC, more or less midnight local time. It identifies a surface urbanite island effect for which the Athens center cools down more slowly than the surrounding areas. This surface urbanite island is a concrete indication of a possible urbanite island which, if prolonged over time, can give rise to a heat wave. Now, we would like to numerically estimate the surface urbanite island effect by comparing the land surface temperature of the hotspot with the one of the surrounding areas. To do so, we add 6 pins in the area surrounding the Athens center. They will represent the reference areas. In absence of the surface urbanite island effect, the land surface temperature of the Athens center should be similar to the one of the 6 selected pixels. In order to see the LST land surface temperature values of the 6 pins, we select the LST night 1 km band. And from the Analysis menu, we open the Statistics tool. We would like to measure the statistics only of the 6 selected pixel pins, so we activate the checkbox to use ROE mask. Then we select the mask corresponding to the pins. Finally, we calculate the statistics on them. From here, we can read the mean temperature of the 6 pins, and we will use this value, that is 297.6 Kelvin, for our surface urbanite island estimation. After taking note of the value, we close the statistic tools. We right-click on the LST night 1 km band in order to launch the Band Maths tool, which allows us to perform calculations using the various bands. We assign the SUHI value as name of the band, and then launch the Edit Expression tool. In the Band Maths expression editor, we add the following formula. We subtract the 6 pins mean value to the land surface temperature of each pixel. When the formula is inserted, we can click on OK. Again, we click on OK on the Band Maths window. The new band is generated and displayed on screen. We then zoom on our study area, the Greater Athens area. From the color manipulation panel, we select the color ramp. Again, we use the 5 colors color ramp. In order to highlight the surface urbanite island effect, we set these range values. The result is a map which colors all pixels whose land surface temperature is above the mean value we indicated. In the Athens center, we can see that the temperature difference is up to 5 degrees with respect to our reference value. This is a numerical estimation of the surface heat island effect. Here, the land surface temperature of the Greater Athens from MODIS Level 3 data from the 30th of July to the 7th of August 2016 is shown, taken more or less at the same daytime. It can be seen how the 4 identified hotspots in this period are almost always present. Here, the land surface temperature of the Greater Athens from MODIS Level 3 data from the 30th of July to the 7th of August is shown, same year, taken more or less at the same night time. It can be seen how, with varying intensity, the surface urbanite island effect is present in the Athens center. Thank you for your attention.